Good morning and welcome to today's T&D World webinar entitled Evolving Our Grid Underground Utilities Powered by Plasma, sponsored by Power Delivery Intelligence Initiative and EarthGrid. I'm Nikki Chandler, Editorial Director of T&D World with Endeavor Business Media. To begin, let me explain how you can participate in today's presentation. First, if you have any technical difficulties during the session, please submit to the questions window and our technical experts can help you out. We do recommend disabling any pop-up blocking software or extensions in your browser, as these can cause issues with the webinar player. Additionally, we do welcome your questions during the event today. We will answer as many questions as possible during the Q&A session that follows the main presentation. But you can send in your questions anytime. Just type your question into that question window on the side of your screen and hit submit. Also, please be aware that today's session is being recorded and will be available on the T&D World website within the next 24 hours. You'll be notified by email when the archive is available. Now, let's get to the discussion by Power Delivery Intelligence Initiative and EarthGrid. I'd like to introduce our discussion moderator, Mike Beeler. Mike, we're always happy to have you leading these discussions. Please go ahead.
Thank you, Nikki. It's a pleasure to be here. Today we have a really interesting topic on plasma drilling and boring. I think you're going to be fascinated by it. So this is brought to you by the members of the Power Delivery Intelligence Initiative. That's a group of contractors, consultants, equipment manufacturers, cable manufacturers, and vendors that advocate for underground. When we look at new systems that we're planning and building, how do they go in, overhead or underground? And PDI Squared, it wants a good, solid look at underground, and we provide the resources to do that. One of the members of PDI Squared is EarthGrid, and today we have two people from EarthGrid with us. Katie Curry, the Vice President. Katie, can you just say a quick hello?
Hi, everyone. Thank you for being here.
So Katie's going to help her CEO, founding CEO, and Chief Innovator, Troy Helming. And Troy is a visionary. He's got a real great vision for what he wants to accomplish across the country and the world, and with some very exciting technology. So on behalf of PDI Squared, we're really thrilled to bring this to you today. So I would say with that, Troy Helming, why don't you take it away? Audience, send in your questions as we go. If we got a question that's relevant during the conversation, we'll try to keep this as a conversation. And then last 15 or 20 minutes, we'll go to Q&A for Troy and for Katie. So Troy Helming, take it away.
Wonderful. Thanks, Mike, and thanks, everybody. So Katie and I will tag team this a bit, and just want to confirm that my screen share is working.
I see it.
Okay, good. Thank you. So just real brief about me, background. I've been in the power industry for nearly 30 years. Primarily developing solar farms and wind farms. I started Tradewind Energy, which was the first wind developer in Kansas in the 1990s, and ultimately became the #1 wind developer in the United States in 2017, and I think #2 or #3 in 2018. It's now part of Enel Green Power. And I had sold most of my shares in 2004 and switched to solar. Pristine Sun has developed about 350 solar projects. And so I've had some exits. I'm also an athlete, been on American Ninja Warrior, and wrote the book, The Clean Power Revolution, about 20 years ago, and talked about how we need 270 new transmission lines to unlock a lot of cheap wind and solar power. And it's very difficult in the United States to build transmission lines. It used to be, 10 or 12 years on average. Now it's 15 and getting worse every year in terms of how long it takes. Katie, you want to give a little background about yourself?
Absolutely. Hi, everyone. My name is Katie Corey. I am the Vice President of Business Development at EarthGrid. I'm very happy to be here with you all, especially talking about my favorite subject, which is all things underground. I am a big environmentalist, and I studied environmental science when I was in college, and I took a class on soil and global sustainability I think, my freshman year and fell in love with all things underground, our ecosystems, how it regulates our environment, how it basically can clean our water, clean our air, and support this lovely life we have here on planet Earth. And that was actually something that bonded Troy and I when we first met. We both have our environmental interests, and when he showed me this technology and I understood what the power of plasma could do underground in terms of, providing energy for the world and all the things that we plan to show you guys, but also how environmentally friendly it was, I fell in love. And so joined the team after exiting from a company that I had founded. And now I get to do something I can't believe I'm so in love with every day. It doesn't feel like work. So we're really excited to share this technology with you. And I'll let Troy get back to the beginning.
Wonderful. So I'm actually talking to you all today from Bernie, California, which is about 4 hours from the San Francisco area. Up here meeting with a utility to look at a project and actually bid on a project to bury some power lines. I'm staring at a transmission tower here. I'm not sure if it's owned by WAPA or PG&E or Pacificor or somebody else, but there's a huge eagle's nest at the top of the transmission tower. And as I was driving up here, I was just noticing, the wide swath of forest that has to be maintained. Vegetation management is a big deal, but the grid is, I'm preaching to the choir here a bit, but the grid and other infrastructure is in need of upgrade. American Society of Civil Engineers gave us a C- grade. We were kind of lucky to get that. We often get a D, D+. And the grid needs a $20 trillion upgrade to support the energy transition. As you see, I'll touch on this statistic here in blue, and then I think Katie will talk about some of the trends she's seeing in the marketplace. But I felt pain for decades as a solar and wind developer, and the statistic in blue is accurate. 80%, 4 out of 5 wind and solar projects are canceled or abandoned, meaning they never get built. And that's after spending like three years or more and at least $500,000, sometimes up to $2 to $5 million of development work before any dirt is ever, any ground is ever broken. And the reason why companies are walking away from these projects is there's simply not enough transmission capacity. It takes often a couple of years to go through the interconnection study queue. Well, it used to be a couple of years. Now it can be much longer, up to 5 to 7 years. But either there's no capacity on the lines or the interconnection upgrade costs are so high that it kills the economics of the project. So our grid is in major need of upgrades. Katie, I think there might be some more you want to add.
Absolutely. Not only is our grid in reasons, but we're seeing today, even with all the technology that we have, that we don't have the capacity to meet what the industry is asking for. And when I first began in this career path, in this job, working for EarthGrid, learning about plasma, learning about the marketplace, we had decided we wanted to put a lot of things in these tunnels. We're exploring a bunch of different avenues. And we decided to just focus on one area just to understand it in its complexity. So we started looking into data centers that basically power all of communication and all the communication basically worldwide. And so I'm going to different conferences and learning that because of AI and because of the rate of growth that we see in our economy and in the world, we're going to need a lot more power. We're going to need a lot more power, and people are struggling to meet that capacity because there isn't a way to develop quickly enough and efficiently enough and for the right price. And also the technology seems to break down, and there's just significant delays to be able to meet the need for power. And so when I bring this technology out into the marketplace, we have a line of people that are just dying for any sort of support they can get to be able to fulfill these different power needs as they develop these data centers. And when I tell them that there's multiple uses for the tunnels and that we can put different kinds of utilities, power, water, fiber, et cetera, as we'll discuss later on, people are elated. And so we need a better solution to not only support the growth for the future, but to be able to even meet the capacity of the now.
Yeah, Katie, that's a good point. I'm glad you mentioned. That. We've got some questions coming in from the audience already, and you mentioned data centers, and this is a big issue because of quick turnaround time data centers need. But one of the questions from the audience, Troy, is what about Houston? Houston just got hammered, hundreds of thousands of people out of service, 10 major transmission lines that went in to feed Houston got hit hard in these storms. Is some of the stuff that EarthGrid's talking about, is that a solution for big cities like Houston? That's a question from the audience. Thank you.
Yeah, great question. Thank you, Mike. Absolutely. Yeah. So, we're here to talk to a utility about burying power lines to hopefully, mitigate or eliminate fire risk on, at least on those lines, or substantially eliminate it. But there's all kinds of risks to overhead infrastructure, power lines, and as well as fiber, cable, other communications. So certainly tornadoes like we've seen in Houston, I mean, that's shocking. 9 or 10 transmission lines are out, and I know that some of the utilities in that region have spent hundreds of millions of dollars over the last decade to harden their systems against, strong storms, and it's just not working. So whether it's a tornado or a hurricane, whether it's ice storms, squirrels and traffic accidents, you name it, there's all kinds of things that are making the grid vulnerable. Yeah. So our ability to bury or to underground power lines, we can do it much faster and cheaper than conventional technology, and we're excited to be another tool in the tool belt for folks. Great. I'll keep moving along here. So according to data actually from the Power Delivery Intelligence Initiative that Mike was referencing earlier, who's helping to sponsor this webinar, underground lines are 9 times more reliable than overhead, with 10 times fewer truck rolls. Truck rolls can include vegetation maintenance, so obviously there's no vegetation in an underground line. Maybe some moss grows, I don't know. But and inspections and so forth. But the key data, and this is from U.S. utilities data, but the key there statistic is 9 times more reliable. Historically, 7 to 20 times more expensive, but that's kind of our fathers or grandfathers' mentality. With modern technology, HDD and other technologies that are out there, micro TBM and things, it's more like probably 2 to 5 times more expensive to put power lines underground. With EarthGrid's technology, we think we can do it for about the same price, maybe a little more, maybe a little less. And depending on what statistic you look at in terms of grids that are overhead versus underground, one of the studies that we've looked at says that Europe's grid, primarily distribution, but a lot of transmission as well, is about 80% underground, whereas North America is only about 8 to 20%, depending on what you look at, and new lines are about 33% underground. So that's it's improving a little bit, but it's happening fairly slowly.
Well, Troy, I think I'll comment on that too. About 18 to 20% of the distribution lines in this country are underground. And there's a lot of old infrastructure that was built in the 50s and 60s that is still overhead. A lot of the new cities or newer cities in the south and southwest and southeast that are being built, new residential neighborhoods are being built underground. And so utilities recognize the value of underground over the life of the asset. I did a webinar recently with utilities that are 85 to 90% underground. You think of Anaheim, Colorado Springs, Loveland, Fort Collins, Beaches Energy, and they have very, very high reliability and excellent resilience in the face of major storms. And it all comes because they are a mostly underground utility. So yes, we can look to Europe, but we can look to certain cities around America as well and see really great examples and some empirical data, frankly, on the value of underground. So back to you, Troy.
A very good point. Thank you, Mike. So I won't read all of these little windows to you all, but I think you can see the data here. I will point out that this slide here is out of date. The actual number of states where EarthGrid has been approved as a telecommunications utility is 46. So Arkansas and Missouri are the last two in the contiguous U.S., and then we'll go tackle Alaska and Hawaii. But what that means is for a project that we're developing with a partner, whether that's a data center like Katie was talking about, or a solar or wind developer that needs a gen tie to get power to a stronger part of the electric grid, and they need a gen tie that's 10 miles or 100 miles away or whatever, we can utilize our telecommunications utility status that we have in 46 states to get preferred access to the public roadways rights of way. So we can't go under somebody's house, or BLM, federal land or something like that without going through certain, procedures and getting their permission. But along public rights of way under state roads, county roads, and city roads, our CPCN status, which stands for Certificate of Public Convenience and Necessity, does give us, like I said, that preferred access. And it's fairly fast. So when we are talking to data centers, and we're talking to a lot of them, including most of the big enterprise data center, household name companies, tech companies that you know of, as well as a lot that, that maybe are not household names. They're, signing deals for nuclear reactors, small modular reactors, and other things because they're just desperate to get the power. And so they're thinking in terms of 5 or 10 years, because that's the only choice they have in some cases. A lot of the utilities around the country have done a terrific job keeping up with demand here initially, but now it's getting to the point where it's not just data centers, it's also factories, it's the electrification of everything. We can provide a solution potentially in 2 to 3 years versus 5 to 10 by, again, utilizing our fast rights-of-way access to get the permitting and rights-of-way, and then putting in a tunnel and a gen tie from a solar or a wind farm to the utility substation that the data center wants us to connect to. All right, so moving on here. Here's a quick image. Hopefully you all can see this, of our first version of a plasma excavator. So we can dig tunnels, or we can dig ditches, or carve out caverns for a ground vault or a substation, or put an entire substation or a subway station, either one, underground. And so the way it works is we use, our two inputs are simply electricity and air. That's it. There's no combustion of any fuels here. We can get our electricity from the grid with a mobile substation, or if we have to use generators, we can, but that's obviously not our first choice. And the way it works is we create effectively plasma by putting an electric arc in that tube you see there. We pass air with powerful air compressors over that very hot electric arc, and it superheats the air to 6,000 degrees Celsius at a minimum, and up to 27,000 degrees in the core, in the center of that plume. And so at that temperature, along with some kinetic energy, some exotic materials from the plasma plume that break down the chemical composition of rock and soil, but pretty much all materials, any type of metal or steel, even diamonds, will melt or vaporize at 6,000 degrees. And so what we focus on is what we call spallation, or we don't call it, it's industry term, but spallation means the rock breaks up into basically sand or gravel or little cornflake-sized bits. This rock you see in the lower right-hand corner is a type of sandstone, but don't let that fool you. It's not soft. It's actually harder than granite. It's called graywacke. This is a 2-kilometer-long project that we did in the California mountains for a wind farm that's under development in that region. So that was one of our projects we completed last year. The tunneling machine, this is a rendition of it. Doesn't look like this exactly because trying to protect our trade secrets, but essentially we have multiple plasma torches on the front. What's not shown here is we also have inlets at the bottom, which are for our vacuum, and also our cooling squid, where we blow cold air on the rock and it causes a faster thermodynamic fracturing, increases our rate of penetration substantially, and it reduces any melting or lava by up to 80%. But the vacuum is an off-the-shelf mining vacuum that we use. It can pull a car-sized pile of gravel up to 8 kilometers or 5 miles at a time per vacuum. And we're not going to sell the machine. Our business model is we have got to have a sense of humor, right? So Boom and Badass are our product names. If we own the tunnel or the trench or the cavern, that would be Boom, build, own, operate, and maintain. You can kind of think of us like an underground real estate developer, where we develop the real estate and we own it and lease out space to utilities who want to put their lines in our tunnel or trench, or fiber, water, whatever it is. And then the badass is boring and drilling as a simple service, is what that spells, or BASS, boring as a service if you prefer. And in that case, if the utility wants to own, own the tunnel or trench,
yeah, you do have a sense of humor, Troy.
gotta do it, right? And by the way, Mike, stop me if any questions pop up, and Katie, feel free to interject anywhere that you'd like.
Finish this thought, and then there's a couple questions here from the audience, and I would like a little bit more description on this really cool looking drill head.
Will do, and we also have a little video that we're going to want to play here in a bit. But we can be up to 10 times lower cost and up to 100 times faster, and this is on tunneling. On trenching, we're maybe not quite as fast, but we can get through anything. You can see some of the statistics here, 152 patent claims published globally, pretty much everywhere except China, and a 2.5 meter diameter, 8-foot tunnel, meaning one that's big enough for people to walk around inside, service the lines, do visual inspections, add, repair splices, add additional circuits or whatever. Typically 5 to 9 million per kilometer, and depending on our price for electricity, we're 1 to 2 million per kilometer or less. And we're crazy fast. Most HDD rigs or tunnel boring rigs that are going through hard rock are getting through anywhere from 10 to 30 meters a day. I just heard last week 2 meters a day at a mine was typical in a mine in South Africa, and a mining company in both South Africa and Australia. And we can go up to 1,000 meters, up to a kilometer per day. And so, as I mentioned earlier, it takes 10 to 20 years to develop a new transmission line because of all the NIMBYs and bananas out there that will slow or stop the project. By going underground, we think we can do it in 1 to 3 years. So I'll pause there. And actually, Mike, before you dive into the questions, Katie, maybe now's a good time to talk about, I know there was a project on the East Coast, data center company that was struggling for a trench. You want to share a little bit about that?
Yeah, absolutely. Did you want me to share about all of our opportunities on the East Coast, or just maybe the one in Mississippi or the ones in Maryland?
Either one. Yeah, actually, how about those two? Sure.
Okay. Well, perfect. This is one of my favorite things to discuss. I'll start with our big opportunity in Maryland. So in my role, I need to find partnerships that make sense for us for where we are in the company and where people might need support getting through hard rock geology. And so we've met quite a few people who need some support in those areas, but just the right amount that fit perfectly into alignment with what we're looking for. And one of those groups is a big developer of communities in Maryland, and they do huge projects, like thousands of acres of land, and they are basically, this group is basically interested in developing in an environmentally friendly way. They have a name for this, and they are developing master communities with thousands of acres and are trying to power everything, the fiber, the water, and everything in a 40-ish mile loop. And they, because of their location, are having a very, very difficult time doing so because the geology is just so hard. They've actually had 3 different construction companies walk off the job site because they were unable to get through the geology. And this is a project that's already well underway, so there's kind of no going backwards. And so they're looking for this type of technology to be able to get through that hard rock geology. And it makes me laugh because when I told them the harder the rock, the better for us, it was like I basically gave them a hug or something. They were so relieved because that's right. For us, the harder the rock, the better, because of what Troy was talking about earlier, the spallation effect. And so we're really excited to be able to start working with these folks and hopefully break through that hard rock geology and get these developments completed. We also have another renewable energy developer in Mississippi, and they're having issues getting under certain types of geology as well as certain types of permitting. And because of our CPCN status and because of our technology, we're able to do sort of these very nuanced types of routes because we're able to use our right of way, and we're able to very, very efficiently get to these little tough areas to be able to create these gen ties. And so we'll be able to do some trenching work with them here in the very near future. And so what I'm noticing about our technology that's different from anything else that's existed before. And the really brilliant way that Troy has structured the CPCN status and all of these things is that we're able to solve some of the most difficult challenges in development that I've seen. And it's something that's not been done before because traditional technology would break down. Traditional technology, and people typically don't have the same CPCN status that EarthGrid has. And they certainly don't have the pinpoint accuracy that our plasma torches seem to have. So there's such a need for what we have, not to mention the speed and all of the other things. I could brag about us probably a little too much for this webinar, but we seem to hit the sweet spot where we're able to solve really difficult problems in an extremely environmentally friendly way, and that's what's necessary to grow and to be able to create the world and the infrastructure that our planet so desperately needs. And so it's a really exciting time for EarthGrid, and we can't wait to share with you guys the updates as they come along.
So Troy, one of the questions from the audience is, do you have a video to show of this process? And I think you do.
We do. So let's turn it over to Janine to show the video. See if, do I need to stop sharing, Janine? There it goes. So these are some videos of the project near Altamont Pass, California. This is some testing work that we've done. The resolution hopefully is coming through okay for everybody. And of course, we'll make this video and the slides available to everyone afterwards. Here's a test tunnel that we bored. You may have seen the picture of me and Noli inside of it. This is a 2.5 meter diameter tunnel that we bored into the side of a cliff there with only one plasma torch, because that's all we had at the time. This machine now has 2 torches, and our 6-torch machine is in manufacturing right now for the tunneling. But in about 30 hours, well, in 22 hours, we removed 22 cubic meters of rock. And this rock is also that same gray whack, that really hard stuff that's harder than granite. So we completed this tunnel as a test. We will be extending it to bring power fiber, water, and sewer lines over to this development, but we wanted to test it out. And here's an image of the 2 torches that can be mounted on an excavator firing up for the first time. No one in the world has ever put 2 plasma torches together on rock until EarthGrid did it last week, and now we're going to have 8 torches doing that.
Well, that opens up, frankly, that opens up a lot of questions. So what's magic about 8? I mean, can you not do with 2 what you can do better with 8? And what about the power requirements for 8? And nobody else in the world is doing this. Where did this technology develop from, Troy?
Yeah, great questions. So it's a little better than linear, meaning the more torches you have, the bigger diameter you can go. And so we, for the tunneling, we don't want to move the torch. They don't articulate or move. They just basically sit on a tractor and go forward. So imagine, a little tractor with lightsabers, basically. So the more torches you have, either the faster you can go or the bigger diameter you can go. Can't have both. It's one or the other. Well, unless you have, even more torches. And then for the excavator, again, having 2 torches, you can remove 2 cubic meters every 40 minutes instead of 1 cubic meter or cubic yard if you prefer. So that's how that works. Oh, and then I guess I should share the origin story. Although let me make sure and see if I gotta go ahead and share my screen again now that the video is done. So hopefully that's working, and I'll go back to my solar company. We had a solar project that was downsized, had to be downsized by 75% because the grid couldn't handle it. So we were drowning our tears over beers at a happy hour in San Francisco, and bemoaning the fact that we had to reduce the project size by 75% because of the grid. Common story, right? Projects that don't get abandoned, by the way, almost all of those have to be downsized. So again, massive upgrades needed to the grid. Anyway, at the happy hour, one of our solar engineers, Dominic, was bragging to his girlfriend about how when he was he's a former Navy SEAL, And when he was on his SEAL team in Afghanistan, or before he deployed to Afghanistan, they were practicing in case there were any, ship things happening, naval things. He was practicing to go underwater, cut ships using a plasma cutting torch. He was like, yeah, that thing could take your arm off. And we were all like, dude, that's amazing. Anyway, the middle of the night that night, I popped out of bed. I was like, huh. He said it was 20,000 degrees. I wonder if that could go through rock. And I just couldn't stop thinking about the idea. That was in 2016. Built the first prototype in 2017. Roughly 7 years of R&D, and now here we are, finally deploying out in the field for customers.
Great. So, haven't I read that there are other companies out there, Troy, that are looking at this kind of technology, and this is a military technology? So, or do you have you've got a lot of patents on that, but isn't Elon Musk thinking about doing something?
Well, yeah, he is, and there's thousands of tunneling companies around the world using, hundreds of different types of machines from dozens of different manufacturers globally, but they pretty much are all mechanical. There are, including Elon's company, the Boring Company, they're using conventional tunnel boring machines, and yes, they've made some clever enhancements to them, but they don't have a solution yet for hard rock. So they actually reached out to us through an investor that a common investor, and so they asked for a proposal, which we gave them to provide a solution for hard rock, and maybe some of our CPCN and project development experience and other expertise. So that was interesting. But yeah, there's really no other company other than GA Drilling. Which GA stands for Geothermal Anywhere. They're using plasma to go vertical. We're using plasma to go horizontal. We're working with GA Drilling. There's really no, competitive tension there because we're in, different markets, and we see some collaboration opportunities. So there's another company, Petra. They have recently been winding down their operations, and we have acquired some of their equipment and hired one of their people already, and bought some of the patents and IP from them. So yeah, we're really the only ones using plasma.
Well, that's great background. I appreciate that, and I asked that question not to be impertinent, but I asked really to demonstrate. I think, and you clearly did, that this is a technology that many people are looking at. That there is a great need in the industry to be filled. The ability to do the tunneling, to do the boring, to build the grid, and to do it much faster and in a much more economic way. So it's a technology that's going to lead us in that direction for sure. And I know you have an even broader vision of the things that you want to accomplish, even broader than electricity. So I say, look, it looks like we're on about slide 16, or so. I think we're on 15 right now, Troy, and having a little bit of an issue with you sharing your screen here. So I'm advancing the slides for you. And we're on 15. So if you want to continue with what you have to say, and we got a lot of great questions coming in from the audience. So thanks to the audience for that. We'll get to those here shortly.
Okay, sounds good. So if I'm gonna have a look here. Oh, I see. Yep, I see where we are. And I'm happy to try to share my screen again if it works. So I'll give it a shot here.
Difficult for some people.
Let me know if it's working.
Well, sharing your screen. So if you sharing your screen makes the I'll advance them for you.
Okay, sounds good. There were some embedded videos there, but yeah, since I'm mobile today, my apologies. Okay, so with respect to kind of where we need to go next, let me make sure I know what slide you're on. Yeah, you can go. We
are on 15 right now.
16. Yeah.
Okay, we're on 16 now.
Yeah, and this shows just kind of a cross section. So instead of a circle like everybody else, we're arranging our torches in a horseshoe shape or a Roman arch, which gives you more usable space to put racks in. For the larger diameter, 2.5 meter, we can do smaller. We can do like a 1 meter, even ½ meter diameter. But our cost is so low that a lot of our customers are telling us, hey, we actually prefer to future-proof it. If you can do this for $1 million a kilometer or less, then, we'd like the bigger tunnel, because we can put power and fiber, and in some cases other things like water or e-commerce delivery tubes for robots, moving things. Like we have agreements with Tubular Networks and Pipe Dream Labs and Magway, 3 robotics companies that want to move our Amazon packages around, or heavy stuff. They can carry up to 250 kilograms per cart, and they can move 10 carts per second through these tubes. So that's kind of interesting. But like the job we're about to bid on here for the utility in Northern California, they want a 3-foot diameter tunnel so that there's enough space for the thermal heat transfer for the transmission line to go. And it's fairly short. It's only about 130 meters, 400 feet, 1 meter diameter. But our cost for a 1 meter diameter is typically comparable to an HDD bore for maybe a 4 to a 6-inch diameter. So we can do a larger tunnel for the same price and give you much better thermal heat dissipation. All right, you can go to the next slide.
Okay, one of the questions as I transition to this next slide from the audience is, do you provide the utility with an estimate prior to you coming in? Are you giving them an estimate, or are you giving them a hard bid?
Yeah, definitely. Although in some cases we've been asked to just do a cost plus type of an arrangement, but we can do it either way. Yes.
Okay. So, slide 17.
Yes, please. So this just shows. Well, we can't show the video here, but this is a test on granite. And again, we'll share the link where you can click on these video links and see it on our YouTube channel or other places. But the granite just basically fractures into multiple pieces after about 3 minutes, and this is about a 1 cubic meter, 1 cubic yard boulder, and it just fractures. And then I'll draw your attention to the ground. You see the gravel and sand on the ground. That's our byproduct. We don't use drilling mud or lubricants or any chemicals, because I've hired companies to do HDD many times for decades, right? And you have to dispose of that wastewater. It's got some stuff in there that's toxic, and that's another big cost, is just disposing of the water. In our case, again, our inputs are electricity and air, so we're not introducing any new chemicals, so nothing can leach into the groundwater. There's nothing to dispose of, and we've even been offered between $30 to $100 per ton for the sand and gravel that are our byproduct. And on any of our tunnels, we're of course lining it with a sprayed concrete or shotcrete mixture, and we recycle or use a portion of the sand that we're creating from our process. We actually put it right back into the tunnel lining, and then the rest of it we can sell.
That's a great business model. One of the questions that came very early on is, what's the power requirement for the plasma compared to maybe like a traditional HED or auger bore? But forget about traditional. What's the power requirement for this? So this looks intense here with this picture splitting this granite rock.
Yeah, it is. That's a 1.2 megawatt torch. It can operate at up to 1.5 megawatts or down to 0.5 megawatts or 500 kilowatts. And the multi-torch systems we're building now are lower powered torches. They're a half megawatt each, so our 6-torch system requires 3 megawatts. A tunnel boring machine that's going to bore a subway tunnel typically requires 10 to 20 megawatts, and we need 3 for our smaller diameter. We would need obviously more for a larger diameter. So we use more power, in some cases at any given moment in time, but the energy budget, because we're so much faster, we're up to 100 times faster, the energy budget is much less, meaning the amount of energy we actually consume is less. So we are working with Caterpillar Energy as well as other companies out there that can provide mobile power solutions. So we can bring natural gas generators, we can bring fuel cells that also run on natural gas, either delivered mobile LPG type of thing or propane, or our first choice is to get a mobile substation and hook up to the grid to power the machine.
Okay, we're on slide 18, but I do have a question here from a utility, and this is a good question. How deep are you going with this, Troy? And what about water, when you hit water?
Yeah, great question. So the depth will depend on whatever engineering firm that we're working with. So if we're working with a utility, they usually will select, whether it's Burns McDonnell, Black and Beach, AECOM, whoever it is. They'll tell us the depth. They'll help us understand the hydrology, the water table issues, and any of the tunnel lining characteristics that we need, like if there needs to be a seismic reinforcement of the tunnel lining. All of those things are not new. Those are well understood problems that have been dealt with for decades in the tunneling industry, and so we'll do the same thing. However, if there is water there, because this is a robot, no humans are inside, we can operate at high pressure, 2 to 3 atmospheres. And that was actually the way for a century. That was the way people would do tunneling. They would use high air pressure to keep the water out, hold the walls up and keep the water out. So that's what we're doing. We're basically creating an airlock in the tunnel. But if water does encroach into the tunnel, it obviously turns to steam, it vaporizes. And in that case, it will slow us down in most rock or geology. But in the case of limestone, it actually speeds us up by up to 20% because of the chemical reaction. So yeah, water is certainly an issue. And depth, typically we're going to be 3 to 5 meters, 10 or 15 feet below grade. And that gets us beneath the spaghetti of everything else that's out there. And it's not so deep that you need really long ladders in your vertical shafts, to get down there. But we're flexible. We can be more shallow, or we could be, if we're going straight through, a mountain, instead of going up and following the road, we could go straight through, and there might be 5 kilometers of mountaintop above us.
Yeah, you just answered a whole bunch of questions that have been coming in. So keep those questions coming. And Troy, I'll just say we're on slide 18, and why don't you keep going on your deck here, because there's really cool stuff coming up still.
Yeah, sure. So you see some of the tunnel projects we've completed. We did a little project for the United States Air Force. You can go to slide 19. It shows the Point Molate, and this is a little more of the statistics there. So 25 cubic meters in 25 hours. We actually removed a total of 40 cubic meters in about 30 to 32 hours. So it was a little more than 1 cubic meter per hour. And that was with one torch. And again, we have a second torch now on the excavator to double the speed. You can go to the next slide. So on the bigger vision that you alluded to, Mike, so look, the United States, we all know this, we need a major grid upgrade. And there's been talk for decades about trying to build a super grid, whether it's overhead or underground. We need a super grid, and I'll be a cheerleader for it regardless of who builds it and whether it's overhead or underground. However, I'm biased, of course, but I think it should be underground. It makes it more resilient from whether it's solar storms or an EMP strike from North Korea or somebody. Whatever it is, it can make our grid much more resilient, and obviously prevent fires and damage to the grid from all of these crazy storms we're seeing. So EarthGrid is excited to announce that we signed a huge deal, a $7 billion joint venture deal with a big infrastructure fund to build thousands of kilometers, thousands of miles of tunnels across the U.S. And so now we're trying to find utilities that want to partner with us, where they want us to connect to their system and make the grid more resilient. And we would ideally like to be able to move large quantities of energy across the 3 grids, the eastern and western interconnects, as well as ERCOT, and connect all of those with underground HVDC. So it's wildly audacious, we know, but it needs to be done, and we can do it much more quickly and much more cheaply, and now we have the capital to do it. So we're very excited about this, and again, looking for utility partners who want to work on that.
That is a great vision. So let me just say, have you started to penetrate into the utility C-suite, or maybe even to regulators, to start to say, this is what we can do, we have the funding, we have the technology, we have the vision? Even if we accomplish half of this vision, have you started to talk to utilities about this?
We have, yeah. We've talked to a handful of utilities. I don't know if I should name any names on this call or not, but some of the biggest utilities in the country, we've started having conversations. We've also talked to some of the ISOs about this and some of the regulators about this as well, and of course some politicians have heard about it too. So it's going to be a 10-year process, right? But we actually have started development of the first 3 projects in Texas and California and some of the western states, as well as a route in New England to PJM. And so those are projects that we're doing active development on. We've talked to over 20, I think we're up to 22 or 23 counties now in those states where we've confirmed that our CPCN utility status gives us access to accelerated rights-of-way. We hope to start construction on the first project in Texas before the end of this year, and on the next projects, the next 2 projects next year.
Well, that's exciting. I don't know the names of any of these utilities that you're engaged with, but I will remind the audience that about 10 or 15 years ago, American Electric Power had a vision for a national grid across America, and it was called I-765, kind of after the interstate system that Eisenhower envisioned with the roads. They wanted to build a 765 kV grid, super grid, around the country, and they solved like 4 or 5 major national challenges with this grid. It was a grand vision. They've only got a couple thousand miles of 765, and they really never brought it to fruition. So this concept is not new for utilities, but the ability to route it and permit it and actually build it today and in the next 10 years, Troy, is something that I think is going to be fully embraced.
Yeah, it needs to be done. And again, we can't do it all ourselves, so we want to have industry partners. Utilities, of course, obviously we want to have lots of great utility partners, but also data centers, as we've talked about, solar and wind developers and others who want to be kind of part of this vision. So again, think of us like an underground real estate developer. We're going to build the underground superhighways, if you will, and we're looking for folks who want to drive on our highways, drive electrons on our highways.
Yeah.
And this map here on slide 21 just shows the states where we are approved as a utility, and the red lines show the first routes that we have funding for and that we have already started development on. Some of these routes, those are kind of draft. The report card on the right is not ours. That comes from ACEG, the Americans for Clean Energy Grid, a nonprofit group that we're working with closely. Just so you know who we have on our team, I'll highlight Kurt Hebert in the bottom right-hand corner. The top is the top row there is our C-suite, but Kurt is a former chairman of FERC, and he actually arranged a meeting with some of the FERC staff and FERC attorneys on one of our data center projects that was going to cross state or is going to cross state lines. And so FERC is aware of what we're doing, and we're fairly excited about about the ability to again solve some of these grid challenges. To his left, Rochelle Chong, former FCC commissioner at the federal level, Federal Communications Commission, also former California Public Utilities Commissioner. I'm going kind of right to left, I guess, in odd order here, sorry. And then Dr. Common, he's at Cal Berkeley. He works with the Department of Energy, Nobel Prize winner. And then on the left, we have an you see board written there. We have an all-female board other than Scott and I, the founders. And you can look them up later, but I will highlight the far lower left-hand corner, Audrey Zibelman. Audrey's the former chair of the New York Public Service Commission. She also is the former COO of PJM, largest grid in the country, and a former executive at Xcel Energy. So we feel like we have a great team, helping us with this grand vision that we have.
I should say so. Congratulations.
Thank you. So we're looking for volunteers and folks who want to work with us or partner with us to help change the world with this tech. Seeing some of the other questions here. Do you want to read those?
Yeah, so we got some questions. Are you ready for some questions? Yeah, thanks to the audience for some great questions. We'll probably go back from your vision back to more of the technology. So here's a question that came early on, and I think Basically it's can plasma technology bore a tunnel directly underneath a ridge line instead of undergrounding near the surface? And I think you talked about going through a mountain. So comment on that a little bit more.
Yeah, that's right. There's really no need for us to change elevation. I mean, if the customer wants us to, we will, but we can go through anything, including really hard granite, really hard basalt. If there's diamonds in there, probably don't want to destroy those with our plasma drill. Might want to harvest those or mine those, but we can go through anything. So yeah, certainly can do that.
Okay. Can this technology be used through soil? You talk a lot about rock, and then talk again about the depth. This person's asking about avoiding underground services, so you're deep enough to avoid those. You can go through any kind of material, so if it's regular soil or sand, you can, but you might open cut that. So comment on that if you would, please.
Yeah, we've tested in soil, sand, clay, loam, wet, dry. We've even put natural gas and propane in our test bed and tested with that, and nothing explodes. It just, acts as a catalyst and just burns. There's very little oxygen. Again, we're not combusting anything, and we can switch our gas from air to nitrogen to eliminate any oxygen if we're going through an area that may have any natural gas or oil deposits, but typically those are not, near the surface, so shallow, like 10 to 15 feet, 3 to 5 meters. Yeah, we go through soil very, very fast. All the organics just vaporize very quickly. We have a whole fire mitigation process if we're trenching. We, of course, have a fire truck or a water truck on site with powerful pump. We spray any of the vegetation with a non-toxic biodegradable product called Komodo, like the dragon. We spray that and nothing will burn. So we have I think it's a 38-page safety plan that we created for some of the utilities we're working with. I wanted to see that.
So here's a couple of questions. When boring through soft ground, soft rock, and clay, does the tunnel have to be lined with concrete or something else, since you're really not getting the melted material that you can use like as a shotcrete? So what do you line in the tunnels with when you go through something that's a lot softer? And can this be used in a downtown urban environment?
So yes and yes. In the softer soil, even in rock, rock is not homogeneous, right? There's soft or fractured rock, or little crevasses or whatever where there might be soil. You can never really predict. Even if you do a bunch of geotechnical boreholes, you never get it 100% accurate. So yeah, in that case, we actually have what we call a paving tractor that follows immediately behind our tunnel boring robot, which has a shield on it to hold up the ground. And the paving tractor injects the grout above the shield as we're going in soft ground, and then as that shield passes by the area, it's already got that that lining, and then it thickens the lining by spraying additional shotcrete concrete mixture with a strong adhesive to hold up the ground. And this is nothing new. This is the kind of stuff that's been done for decades. But we had to talk to our supplier that's doing this, or suppliers, to get them to add additional spraying wands to their rig, because we're going so fast. They couldn't keep up with our speed. So instead of one arm spraying, it's going to be at least 3 to 5 arms spraying to keep up with our speed.
Okay.
Going up.
Here's a question from the utility. Can you expand on the criteria for using the $7 billion? For example, do projects have to connect to the eastern-western interconnection or ERCOT, or could some of those funds be utilized within one of those areas alone?
Oh, definitely within those areas. There's going to be a lot of little short hops. Like, each of these long projects are going to be broken up into probably 30 to 50 individual segments, and we can zig and zag any direction we need to go. If we find a utility that says, hey, I want this 20-mile route over here, can you do this for me? Absolutely. And then we would just potentially, if it works, we would just extend that route in both directions to connect to our larger network.
Here's 3 questions in a row regarding financing. Do you have the financing you need to complete the projects? Are you looking for investors? And is there any Biden infrastructure money in any of this?
Always looking for investors. Thank you. And we do have capital lined up for the projects that I already mentioned, but there's other projects that are in need of capital. So yeah, please reach out to us. You can send info info@earthgrid.io, or to Troy at earthgrid.io, or to Katie, Kattie, at earthgrid.io. Yeah, so feel free to do that. And yes, we've applied for grants with the Biden infrastructure, and we are in the process of finalizing an application to the Loan Program Office. We don't have any of it yet, but we are certainly looking to try to get some of that. And we're looking to work with people who have been awarded funding from infrastructure, where they have funding to build out a fiber network or a power line network or whatever, and they want to make sure their project stays within budget and maybe even happens faster. That's where you can bring us in to help.
Okay, here's the last question from the audience, and then we'll go ahead and wrap it up. But these are great questions from the audience. Thank you very much. Are you considering the plasma technology for transmission lines, or does it have the potential to be applied to distribution grids as well?
Both, for sure, both.
Yeah, I would agree. Okay, that was a quick answer. How about seismic? Any seismic risk when you're that far underground? What's the tunnel look like? Do you do anything with the tunnel differently? Or you'll anticipate that with your engineers?
Exactly. The engineers will tell us that we're in a seismic zone, and we'll add additional reinforcement to the tunnel in those areas.
Okay. Okay. Well, I think we got through most of the questions, and we're at almost at the top of the hour. Katie, you've been there, and I will just give you a minute to give any kind of concluding remarks, and a thank you to the audience for listening in today.
Well, thank you so much for having us, and it was great to meet with all of you and be able to share this amazing technology. If you guys have any questions or any projects or any sort of partnership opportunities, I would love to hear from you. Please send me an email. My email is Katie, Kattie, at earthgrid.io. And thank you all so much just for your time and for your interest in this technology. We truly, truly believe at the core of our hearts that this could change the world, and we'd love for you guys to be a part. So thank you again for your time, and hope to hear from you all soon.
Yeah, Katie, thank you very much. I appreciate your passion for this technology and for the things that it can accomplish. And so that it goes a long, long way in this industry. Troy, you're a visionary. You're the founding CEO, the innovator, the head cheerleader, a visionary of something that's very, very grand and very exciting to listen to you. Give us some concluding remarks today, if you would, please.
Yeah, will do. First of all, thank you everybody for spending an hour with us today and learning about this new technology and how we can solve a lot of problems. You know, whether it's trenching or tunneling or carving out, you know, caves or caverns for any reason, underground substations or switchgear, any of that kind of thing. Every project, every job is a little bit different. We're happy to come in and, you know, have conversations and take a look at what it is that you want us to help you with. So we're eager to change the industry and change the world, like Katie said. So give us a chance to prove ourselves.
Well, that was excellent, and it's a fascinating technology, and really appreciate the fact that you're part of the Power Delivery Intelligence Initiative and that we had a chance to share this technology with the industry today. And we're going to turn it over here to Nikki Chandler pretty quick, and she'll tell you that the archived webinar is going to be available to you, and she'll tell you how you can get that. But I'd just like to say on the behalf of the members of the Power Delivery Intelligence Initiative, really appreciate everybody listening in today. My name is Mike Beeler. I'm the national spokesperson, and it was a thrill to be here today. So thank you, Katie. Thank you, Troy. And Nikki Chandler, back to you.
Thank you, Mike. Yes, very interesting session today. I appreciate all of you presenting. And yeah, that archive will be available on the T&D World website, and we should be getting those out to all the link to that to the registrants as well in email. And then for any questions that we didn't get time to answer today, we'll be getting back to you via email. That does conclude the presentation. And so on behalf of T&D World, I'd like to thank our speakers for their discussion, PDX Grid and EarthGrid for sponsoring the webinar, and of course, all of you for joining. Have a great rest of your day.